This is section 7.4, concepts of probability. So we're going to go a little bit deeper, not much, into the idea of probability. We have a union rule for probability. This is for any event, E and F. So the rule is that the probability of E union F is equal to the probability of E, that event, plus the probability of F, minus the probability of the intersection of the two. So let's look at that in an example. Find the probability of drawing a card and it being red or a face card. So the probability of R union F, that it will be a red or a face card. Well, the probability of red plus the probability of a face card minus the probability of that intersection. So the probability of it being a red is there's 26 red cards out of 52. Face cards, there are 12 face cards out of 52 minus, now, how many in the deck are red and a face card? There's 6 red face cards, so that would be 6 out of 52. So you add these two, you get 38 50-seconds minus 6 over 52 is equal to 32 over 52, and 4 goes into that 8 times, 4 goes into that 52 13 times. So we have 8 out of 13 is the probability that you will draw a card and it being red or a face card. The complement rule says the probability of an event equals 1 minus the probability of E prime, or the probability of E prime is equal to 1 minus the probability of the event happening. And this comes into play when we talk about odds. You hear about horse racing or other kinds of gambling where odds are talked about. Well, here's the actual math of that. The odds in favor of an event E are defined as the ratio of the probability that it will happen to the probability that it will not happen. So it's P of E over P of E prime, where this number is not 0. All right, so we're going to use that in a couple of problems in this set. And again, we're not going into this very deeply, just touching on this in general. All right, let's look at our problems. Let's see. I'll make this a little smaller. All right, decide whether the events are mutually exclusive. Owning a dog and owning an MP3 player. So if you own a dog, does it mean you cannot own an MP3 player? No, those are not exclusive, mutually exclusive. Number 2, being trustworthy and being employed. Are those mutually exclusive? If you're employed, does it mean you can't be trustworthy? No, those are not. So think of it, if I gave you, can an animal be a dog and a cat? Nope, those are mutually exclusive. So that's the idea we're talking about. One more here. Being a screenwriter and being under 30. If you're under 30, can you not be a screenwriter? If you are a screenwriter, could you not be under 30? Those are not mutually exclusive. All right, a pair of dice is rolled. What's the probability of getting a sum of 10? And they had this chart in the book, and I went ahead and grabbed it for you. What's the probability of getting a sum of 10? So if you roll the dice and you have a 1 and a 1, you get a sum of 2. There's 2 possibilities. Either you get a 1 and a 2 or a 2 and a 1. You're going to have 3. So those are all laid out here for you. And so to get a 10, you could roll a 4 and a 6, a 5 and a 5, or a 6 and a 4. So that's 3 in that event that would give you 10. And the number in the sample space, if you total all of these up, is 36. So we're going to use this number, and we can look at the chart for future questions. Okay? So the number for that event would be 3 out of 36. So that's a 1 in 12 probability that you would get a sum of 10. All right, what's the probability of getting a sum greater than 10? So if we look here, 11 or 12, there's 1, 2, 3 in that. We're just going to use the chart. So that again would be 3 out of 36 or 1/12. What's the probability of getting a sum less than 10? So if we go back up here, we've got all of these would give us a sum less than 10, and if we count them up, if you count up all of those, you're going to get 30. So 30 out of 36 is 5/6. So feel free to use that chart. What is the probability of getting either a sum of 5 or at least 1 4 in the roll of a pair of dice? All right, let's look. I think I've got it written here for us. All right, so using that rule that we have here, that I gave you at the beginning, so we need the probability of the event, the first event. So what's the probability that we'll have a sum of 5 plus the probability that we'll have at least a 4 minus the intersection of those two? All right, the probability for a sum of 5. Let's go back to our chart. So sum of 5, there's 1, 2, 3, 4 in that event. So that's 4 out of the total was 36, so that's a 1/9. The probability of at least a 4, if we go back to our chart, and if you count up every event that has a 4 in it, you have a total of 11 out of 36. Now, what's the probability of a sum of 5 intersect at least a 4? So if we go back to our sum of 5, how many of those have a 4 in them? That's 2. So that's the intersection of that. So 2 out of 36 is 1/18. So we've got 1/9 plus 11/36 minus 1/18. Let's change all those to the common denominator of 36. So we have 4/36 plus 11 and then minus 2. So that's 15 minus 2. That's 13/36 is our final answer. All right, then I omitted number 7 when I actually assigned the homework. Let's go to number 8. Mathematics faculty at a college consists of 7 professors, 9 associate professors, 6 assistant, and 7 instructors. If one faculty member is randomly selected, find the probability of choosing a professor or an instructor. So if A and B are mutually exclusive events, P of A or B equals P of A plus P of B. So the number of the sample space, add up the number of faculty total, so 7 plus 9 plus 6 plus 7, and we get 29. So that's our N of S. The number of professors is 7, so we have 7 out of 29. The number of instructors was 7. We have again 7 out of 29. So the probability of choosing a professor or an instructor is 14 out of 29. Okay? A marble is selected at random from a jar containing 2 red, 3 yellow, and 6 green. What are the odds in favor of selecting a red? All right, remember this was our formula for odds. And so the probability of the event is 2 out of 11. There were 11 total marbles. So if the probability of getting a red is 2 out of 11, then E prime, the probability of that, is 9 out of 11, because that's 1 minus that, remember? So the odds are the probability that it will happen divided by the probability that it won't. And when you have a complex fraction, you flip this guy and multiply. So you have 2 over 11 times 11 over 9. Those cancel out, and you are left with 2 over 9, which is your odds. That's the odds that you will get a red marble. All right. So I think that's our brief encounter with the concepts of probability, and that should help you with 7-4.